Should be live, I think, give or take. Hey, what's going on today, YouTube? Well, I've decided that I'm just going to stream some stuff that I'm working on and checking out. So, I was gonna do this offline, but figured I might as well do it online and show you guys what we'll be taking a look at. So, I've got archive pulled up on the screen. There were some papers and stuff that I thought were cool that came out that I wanted to share. Um, and yeah, well, just gonna go through them, listen to some stuff, and just talk about them in general. So, yeah, things have been, I'd say, fairly busy. I've been looking at many things recently, and there's a lot of stuff that I want to try to implement that are beyond my level, but you know, we've got the power of AI to help us to do those type of things nowadays, so I don't think it's too far beyond reach, but I don't know. We'll see. We'll see once once I get to trying it out. But yeah, right now, just pulled up TTS on archive, and we'll just check out some of the stuff here. So I'll just be going through it, and that'll be what I'll be doing right now. So okay, yeah, I often go to just archive and search up TTS if I'm just looking for some new stuff that I want to review, or just to see if there's anything cool that's come out. There is one text-to-speech system that is going to be coming out that is open source, that should be being released by Billy. It's Chinese. Sometime in the future. It's called Index TTS 2. We'll take a listen to that in a little bit, but I think it sounds pretty cool. And if that model gets released, well, I can see it being pretty good, maybe monumental. But I'll go over that in a little bit. But okay, first paper. Let's see what we got here. TTS-CtrlNet. Fine-grained time-varying emotion control remains challenging. Yes, that is true. Customizability and being able to control text-to-speech, we completely need. We need more of that. Okay. And I am not a machine learning engineer by a long shot, but I still kind of get the general gist of what is being talked about. So, hoping to change that a little bit. But in the meantime, we can take a listen and look at some of these papers to see how they sound and see what we've got. So, reference audio is constructed by concatenating two speech samples expressing a different emotion to explicitly include multiple emotion cues. Okay, let's see this. Alright, you guys cannot hear this. Let me change this so you guys can hear it. Let's see. Come on, OBS. OBS. Yeah, for some reason, okay, so what I'm trying to do right now, I'm trying to change what is playing on OBS so you guys can hear the audio, running the audio issues.
Kids.
Oh, there it is. Okay, cool. So you guys should be able to hear what I am hearing now. So it looks like we have an audio prompt. Concatenating two speech samples, angry, calm. So I guess we'll have an angry, calm output. I don't know. Let's listen to the audio prompt.
Kids are talking by the door. Kids are talking by the door.
All right.
Dogs are sitting by the door. Dogs are sitting by the door. Dogs are sitting by the door. Dogs are sitting by the door.
Okay.
Dogs are sitting by the door. Dogs are sitting by the door.
Okay, that's pretty cool.
Dogs are sitting by the door. Dogs are sitting by the door.
Mm-hmm.
Dogs are sitting by the door. Dogs are sitting by the door.
Oh, interesting. This is higher fidelity, so maybe 48K or 44K that it's outputting as. Let's listen to that again.
Dogs are sitting by the door. Dogs are sitting by the door.
Okay, yeah, that definitely sounds better than the other ones. This Emo Control TTS and Elate were research papers by Microsoft where they had kind of controllability over the output audio through speech prompts, audio prompts. So we haven't seen it be implemented open source yet. I didn't get to check to see if they're gonna release the code for this, which I don't think they are. What's the paper? View PDF. Okay, they have a project page. Doesn't look like we have a link to a GitHub repository for the code that they have for this, but it seems I would assume that there's maybe enough in here to recreate it. But yeah, no, it doesn't look like there's any links to the repository if they're going to release the code or whatnot. So I will go ahead and move on to the next one. Usually when I look through these, I'm generally interested in models that are released openly so that we can play around with them or will be being released openly. I see that this is a university. Sometimes if I see certain companies like Alibaba, or Microsoft or Google, I know they're not going to release their models. They're just going to release their research. So sometimes I don't really pay attention to those too much. But let me see what if there's anything else here. Japanese to English, speech to speech translation. Let's see.
今日は友達にたくさん手伝ってもらってとっても感謝してるんだ。本当にありがたい。
Okay,
I'm really grateful for all the help my friends gave me today. It's truly appreciated.
Okay, and then
I'm really grateful for all the help my friends gave me today. It's truly appreciated.
oh, so this missed the laughter on there. Okay, cool. So yeah, this seems to be a work in the direction towards more controllable text-to-speech based on emotion prompts, which is awesome. Love to see it. Don't think this is going to be released openly, but yeah, we'll move around and just check out some other papers here. What's up, Misty Tom? Thank you for tuning in. Do I recommend Zonos TTS? I do. So I tested Zonos out a few months ago, and I think it's a fairly solid TTS model that has multilingual capabilities. I could see it being fairly good because you can control like the emotion with these sliders, right? So I'd say if you need a TTS solution, Zonos is pretty good. I haven't done extensive usage, or I haven't tested it out extensively though, so yeah, there's that. Let's see what else we got here. This is Watermarking TTS. I think first work towards watermark free TTS with strong. Oh, interesting. So they're working towards I'll probably take a look at this later in my off time. Watermarking text-to-speech without having a watermark inside of the embedded into the text-to-speech audio. I know Chatterbox watermarks their text-to-speech audio by using something called Perth, I think. So yeah, you can trace it back to Chatterbox. Al C, thank you for tuning in. Of course, I hope you find the audiobook maker useful. If you are an active user of it, or you know, if you need anything else for it, I will probably be going to do a little bit of development on the audiobook maker. I want to add the Chatterbox TTS engine into it. I also need to add a few more things to it, like XTTS I need to add into the audiobook maker. And then, yeah, the XTTS license works with my audiobook maker license, so I think it should be fine to add that. Yeah, I don't know if Zonos natively outputs 24K or 48K. I don't know, but yeah, usually they make it more crisp by trying to either upscale it to like 48K or having a model later to output it to 48K. But that results in weird frequencies. Oh, max is 24? Ah, gotcha. Yeah, I'd say open source model Zonos is fairly good. I just had like some bad experiences with trying to get it set up on Windows, where I was like, okay, I don't want to work on this too much, because I was trying to get it compiled so that I could run faster on Windows using Triton, but yeah, that's too much of a headache. I got it working like once and then it stopped. I was like, oh my gosh. But yeah, it works just fine on Ubuntu or WSL2. Open source system for multilingual translation and cloned speech synthesis. Is a text-to-speech module maintaining. Let's see if this has any audio samples. Let's see. Oh, I think I saw this the other day. No, I didn't have anything. What's up, Mike? Thank you for tuning in. Have I checked out voice coding with voice modeled MCP yet? Not gotten the chance to check it out or anything like that. Been a little busy with some other things, so to be honest, probably voice coding. I probably wouldn't do it too much, because currently right now what I'm using is Claude Code. So here we are inside of Cursor. So I use Claude Code for pretty much everything. I think it's really solid, and oh my gosh, it works for me. It integrates much better into projects. So like for this, if I want to have a script created, I could just describe the script and it'll create it, which is very nice. And I don't know if voice is able to be integrated into it, so yeah. Yeah, we could always, yeah. You could resample the audio to 48K. It doesn't really help because you're not able to, recapture any of the lost frequencies. However, they do have some, there is a repository out there that you can use to upscale it generatively, which is called APBWE, I think, and I think it works. I think it works fairly well. So we've got this repository right here, so you can upscale things from like 16K to like 48K, and this repository does work fairly well. So yeah, give it a shot. Check it out. Oh, so this was interesting. I saw this the other day. This is not text-to-speech, but this is a large language model that claims to reach OpenAI O3's performance while being 32 billion parameters. It says they've open sourced it, so yeah, I was gonna take a look at this the other day, but yeah, I didn't get the time to download it. So 32B. I don't think I can run this natively. I could probably run a quantized version of it. Yeah, it doesn't look like they have any quantized versions of their model. But yeah, I could probably try out their 7B and check this out. But yeah, this isn't text-to-speech. This is an LLM. And yeah, this would be something interesting to check out and try. Oh, you built it for Claude Code? Well, that's pretty good. How did you integrate it into the Claude Code? Yeah, I was like, generally, I was like, I can see myself using a voice assistant sometime in the future. Right now, what ends up happening is if I try to speak, what ends up happening is I am better able to formulate what I want via text, or via typing rather than speaking. And so that's pretty much why I would hesitate to currently, or to integrate a voice solution into my workflow. But you know, I might check it out for content if it's possible. Like there was a you know, I used to write essays with Google Docs's text to speech. So where you could read out what you want inside of an essay, and then you could say like period or delete period, and it would do that type of stuff, and it would continue to build your essay as you're just talking it out. But you know, I found it was just easier to type things out. It was cool, but it didn't make my workflow any faster. Okay, speech accent LLM. Foreign accent. So there are a few papers that I saw that were interesting, and they were surrounding text to speech or accent conversion, from let's say like an Indian accent to a native English speaker accent, which I thought was pretty cool. So let me just, instead of you know, checking out all these other things, let me just scroll down to a few papers that I wanted to go over. So we've got this paper here called Index TTS 2, and this is released by Bilibili, and I found this I found the outputs for this to be fairly impressive. And yeah, Bilibili, so it's a Chinese model, and we'll scroll down to where they have a link to where we can listen to some of their outputs. Let's see. Here it is. So this model, they say, is going to be released openly, and there is a Index TTS 1 that exists by this research group, I think. So yeah, there's an Index TTS 1, and then there's going to now be an Index TTS 2. So they are able to what I find cool about this is that it's able to translate from one language to another while maintaining that same style of speech. And so I was like, can I play these on stream without copyright stuff? I don't know. Regardless, here, but yeah, for example, we've got like this audio visual dubbing. I'll just play one of them, and then we'll take a listen to it. We've got Chinese and then English. So this is like an example use case here.
臣妾要告发熹贵妃私通，秽乱后宫，罪不容诛。
宫规森严，几个人不得信口雌黄。
臣妾若有半句虚言，便将五雷轰顶，永不超生。I report consort exceed committing adultery, defiling the harem, a crime worthy of death.
The palace is strict. No false rumors, Lady Qi.
If I lie, may I be struck by lightning and never reincarnate.
So this is a model that is able to do that is able to keep the flow of the original language, it seems like, and output it in the desired language, which I find to be lacking currently in current implementations of text-to-speech. So this I could see being maybe at like the forefront for dubbing, which would be pretty cool. So this is a paper to look out for, or a engine to look out for. So there's a lot of different samples in here, and based on their previous works, it seems like they are going to be releasing this to the public. Let's see, where does it say that at? Oh yeah. To promote further research and facilitate practical adaptation, we will release both the model weights and inference code, enabling the community to reproduce and build upon our work. So if they're going to be releasing this model out publicly, we might be able to start getting some actual or some accurate dubbing TTS models, which I will definitely be checking out and doing for anime, of course. So yeah, we'll see how this goes. So I'm excited for this one to come out, but we'll have to trace it and track it. And then there are some other ones that I wanted to check out too. So Lyric Boss, the AI voice changer is great, but it's known to take up a lot of memory when usage. So you've got two different voice changers. You've got the Beatrice one, and then you've got the W Okada RVC Beatrice. Sorry, let me go back. You've got W Okada, which you can use with Beatrice, and then RVC. RVC requires you to use a GPU, and then the Beatrice you can use on the CPU, which is RAM. So if you are using these models, you most likely will not be needing to upgrade your RAM. I'd recommend that you have a larger GPU with more VRAM. So not a lot of models run on the CPU, especially for the voice changer. You can run it with the CPU, but I don't know if more RAM is going to be useful for that case. Oh, and then Mike, I don't know if you can send links in YouTube. So if you just wanted to give me like a repo name or something like that, that would be preferred. But yeah, no, I could totally see that. Yeah, instead of having to sit down to type, you could be able to get things done. I still hesitate to say that I would use it. I don't think I could think correctly while vacuuming, or if I'm taking a bath, I don't want to be coding. If I'm taking a bath, I want to relax. Okay, so yeah, there was that Index TTS2 paper that I saw, and then there was this other paper that got released, which is supposed to be accent conversion. Now, this isn't open sourced or anything like that, but I found this to be fairly impressive. And this is from Carnegie Mellon University, or maybe a mixture of two people or two groups. But it says that their paper was supported by Zoom Video, or a grant by Zoom Video. So what I imagine is happening behind the scenes is Zoom, the video calling application, Zoom is going to be working on AI or is going to be looking into AI that can convert accents, which is very interesting to see. So, the fact that the research grant is, part given by Zoom, it seems that Zoom is looking into being able to convert accents to make certain, conversation flow a little bit better, and whatnot. So, yeah, we'll take a listen to like these video examples here, and yeah. So, AAA gaming. Soon, I won't need to be coding either. That is true. Yeah, we won't need to be coding. I don't know. We'll see. We'll see when that happens. Currently, right now, you should still understand how the flow of code works, or else you will be lost once once AI is not able to do it properly. But yes, in time, I think we won't need to code at all. But this model here is able to convert accents to a more native English speaking accent. So I can see this being fairly useful for people that don't want to hear the accent. So we'll take a listen to this first video here.
TV news. The media holds a mirror up to society. But who will hold a...
Yeah, let me restart that so you can see the lip syncing.
TV news.
Oh, I guess there is no
The
lip syncing
media
here.
holds a mirror up to society. But who will hold a mirror up to the media? Who will hold the press accountable?
Okay, so let's try it, and then we'll do the one with the conversion.
TV news. The media holds a mirror up to society. But who will hold a mirror up to the media? Who will hold the press accountable? I'm part of the media, and I think we need to have this conversation now.
So there we can see that the accent was what was it? The accent was converted to a more native pronunciation of English. And then let's try this guy out here.
To the world, to the neighboring kingdoms. So who was showcasing culture? Artists were showcasing culture. Dancers, musicians, poets, people with great literary works. And then what happened? The kings disappeared. And we lived in the world of democracy. I'm sure life was better.
Okay, so there's that little snippet, and then here it is.
To the world, to the neighboring kingdoms. So who was showcasing culture? Artists were showcasing culture. Dancers, musicians, poets, people with great literary works. And then what happened? The kings disappeared. And we lived in the world of democracy. I'm sure life is better, but not so good for the artists at that point.
And so this I could see being fairly useful. You know, you have your input with the Indian accent, and then it has the output video with the accent conversion and improved pronunciation. So I could see this being fairly useful for a company such as Zoom to be able to implement this. And so they, you know, the paper goes over the streaming model that they were able to do. And I don't know, I could see this being very handy for things like a accent converter, AI voice changer or something. What's up, Johnny? Thank you for tuning in. I'm just currently going over some AI TTS stuff and some things I find interesting, and then we'll probably be working a little bit, and then that's gonna be it. Excuse me. But yeah, we have like this we have this model that's able to convert like other accents into a improved pronunciation version for English. So that's fairly cool. Now, one thing that I was reading this paper a little bit, they do require a data set that has they require a data set with, let's say, a accented version and then an equally unaccented version. And so I could see a data set for that being very hard to get. So the reason that I got interested also in this too is if we go into Chatterbox TTS right here, I am currently generating a data set with Japanese accented voices and then native English sounding voices. And so we could technically create a data set for this type of accent conversion model and get that going. So we'll take a listen to this real quick, and I'll show you guys what I mean by that. Let me go ahead and let's see. Okay, so we have, like I said, for an accent conversion model, you need a native sounding speaker for that same sentence, and then you need an accented sounding speaker for that same sentence, which is generally hard to get. But you can augment and create a data set with that with these text-to-speech models. So that paper used a fine-tuned VITS model, I think, but we can actually generate it with Chatterbox TTS. So here are the two samples that we've got: Japanese accent and the native accent.
In the only sense with which we are at present concerned, differs from most, if not from all, the arts and crafts represented in the exhibition.
And then the no accent.
Printing, in the only sense with which we are at present concerned, differs from most, if not from, all the arts and crafts represented in the exhibition.
So we can see that we have the same sentence, one with an accent, one without one with an accent, and one without an accent. And this could be very important for training a model like that. So I'm currently generating a data set right now. That's what we got going on here in the command line. I even have me in the data set here.
Printing, in the only sense with which we are at present concerned, differs from most, if not from, all the arts and crafts represented in the exhibition. Printing, in the only sense with which we are at present concerned, differs from most, if not from, all the arts and crafts represented in the exhibition.
So that's supposed to be me. So we've got an accented one and a native one. And so I'm just creating kind of like a mock data set just to see if we could replicate this maybe locally. And so, yeah, I'm currently working on some things with that, trying to get it up and running, even though my knowledge of creating architecture from paper is next to zero. So, yeah, we'll see how that goes. I'll be using AI tools to help me see if I can try to implement this. But yeah, we'll see. We'll see how that goes. Crafting, F5, Chatterbox, or Qtie. I didn't have a positive experience with Qtie. Qtie Moshi, right? Qtie Moshi Labs. Yeah, I didn't have too much of a positive experience with this one. So I would recommend Chatterbox. I think Chatterbox is more controllable than F5 TTS and sounds better. A Qtie, I think, is also, you can't fine tune it or anything like that, or Moshi. So yeah, I would go with more of the F5 TTS or Chatterbox models. F5 TTS is a little bit easier to get up and going, I think, but Chatterbox is also fairly easy. I'd say they're both fairly easy to get up and going. Yeah, so that is those are the two kind of papers that I wanted to go over and review, which was the Index TTS 2, which is going to be cool for translation dubbing. So we'll see that. We'll see how that comes around. And then we've got this this accent conversion model for pronunciation improvement that isn't open sourced, but it looks like there's enough in this paper to be able to replicate it. And so the only thing I think that would be lacking is maybe a data set. And that data set is something that can be generated, which I found out with Chatterbox TTS. So, oh yeah, Chatterbox can do real-time streaming. So there is actually a guy, or the guy, who creates like the TTS web UI. If you're inside of the Resemble AI Discord, you can go to the Chatterbox area, who has found out a way to make it faster. And we got Chatterbox TTS faster Reddit. Okay, somewhere in there. But yeah, there's the guy who creates it is fairly active on the Resemble AI Discord, and he's found a way to make it almost 2x faster. I haven't gotten a chance to try it, but it has something to do with compile, I think. Let me see if I can find it. I think it's this right here. Here. Yeah, F5 TTS is solid. I don't think you can go wrong with either F5 or Chatterbox. So they're both fairly easy to get up and going. I recommend you just that's the beauty about the open source models. Yeah, you can just download them and try them out, and see what works best for your use case. I know some people still rave and crave over Style TTS 2, even though Style TTS 2 I think doesn't sound the best. Style TTS 2 is very fast and sounds very good. But yeah, here is the here's Dasser's Reddit post about optimized Chatterbox TTS. It says up to 2 to 4x non-batched speed up. And so I could maybe test this out actually on stream. Maybe we'll try that, see if we're able to implement it into our code base to make it faster. But yeah, the last time, yeah, I'm just kind of into the AI audio area. I was working on RVC stuff. I have like these waves of motivation for certain technologies. Like the RVC stuff is cool. I don't think there's been much improvement in the RVC area. If we go to RVC GitHub, yada yada yada. Yeah, I think it's still, yeah, I'd say it's fairly old. But I mean, SeedVC is another speech-to-speech model that I think is very solid. I also haven't gotten more time to look at. I actually think like the zero shot for SeedVC is very good. So if you haven't checked it out, check it out. But yeah, Chatterbox is kind of like a Mike, do you know why I recommend Chatterbox? You haven't looked at it or anything? I'll probably give like a short demo, or a short demonstration. So if I pull up, let me see. If I pull up a interface, let me stop the dataset generation that I'm doing right now. If I pull up the Gradio interface, we got a few things with Chatterbox TTS that makes it different than F5, I believe. We've got an exaggeration slider, and then we've got like the CFG parameter that we can change. And I forget exactly what the CFG does. And then we can now launch this local host 3860. So we can just, we can choose a model to use, choose a tokenizer, and then we can do like voice cloning. We'll use me. Use English, turn this off. So we can grab a sentence. I don't know, we'll just grab the sentence from Reddit and then inference on it. So we can exaggerate it. Well, let's do low exaggeration, then we'll do high exaggeration. So we'll do low exaggeration here, 0.2. And then we'll do higher exaggeration. Yeah, CFG. Let me search that up real quick. Chatterbox TTS GitHub. The CFG slider. Yeah, I actually don't know what the CFG is for, but it says if you lower it, it can improve pacing. But here is low exaggeration for the sentence. You guys can't hear it, huh? Let me change the audio. You hear now? Okay, so you can hear it. So this is Chatterbox with low exaggeration.
Even without that, you should see faster speeds due to removal of CUDA synchronization and more aggressive caching. But in my case, the CPU Windows Python is too slow to fully saturate the GPU without compilation.
So that's low exaggeration, and let me crank up exaggeration up to 2, and then we can see how that changes the output of the audio sample.
Even without that, you should see faster speeds due to removal of CUDA synchronization and more aggressive caching. But in my case, the CPU Windows Python is too slow to fully saturate the GPU without compilation.
Okay, so there you can see it's got exaggeration, and it also picked up on a Japanese accent. That's because this is a Japanese English trained model. So let me just language conversion it to be more English in its desired accent, and we'll re-listen to that. That was kind of unintended.
3. Even without data, you should see faster speeds due to removal of GPU that sync.
Okay, it's even more exaggerated now too. So yeah, it's supposed to help out a little bit, but yeah, maybe exaggeration at 2. Let me use the default model, disable this, and I'll show you the exaggeration with emotional intensity higher. I actually didn't know that. So exaggeration with a mixed model can pull the accent into that, so that's good to know. Alright, so it's got to reload the other model in here. And what's up, guys? Welcome in. Thank you for tuning in. Currently just going over Chatterbox TTS. One of the viewers said that they had never used or seen Chatterbox TTS, so just going over it. So here it is.
Even without that, you should see faster speeds due to removal of CUDA synchronization and more aggressive caching. But in my case, the GPU Windows Python is too slow to fully saturate the GPU without compilation.
So there we go. There's an exaggeration of 2, and we'll lower it one more time just to listen to that.
Even without that, you should see faster speeds due to removal of CUDA synchronization and more aggressive caching. But in my case, the CPU Windows Python is too slow to fully saturate the GPU without compilation.
So that was actually interesting. The exaggeration amount actually did induce an accent on my voice. So I don't know. Maybe my voice is accented for English. Who knows? But this is the reference audio. You guys can't hear it. Hold on. Let me just create a different audio element for freaking cursor. Add edge audio. Where is edge? Let's see. There we go. I think this is it.
Even.
Okay. So I've got edge audio, and then let me make a cursor audio. Okay, so you should be able to hear the reference audio for me as well now too.
Generate 2. It's going to all of them. So let's go ahead and click generate down here in this bottom right corner. Generate. It's going to generate a response.
Okay, so that's the reference audio, and if you remember the samples earlier, it was exaggerated. So yeah. Oh yeah, that was a generation. So yeah, Chatterbox is really good. It allows you to do the exaggeration, which is fantastic. Like, you know, it's very random on how it is, but yeah, we could even like do this on like a different voice and see how that goes. But yeah, Artycraft, that's Chatterbox. I think it's fairly cool. It's pretty nice. And if you're asking about a fine-tuning guide, I do not have a fine-tuning guide on it yet. That's what I was going to be working on, but my code is super messy, and yeah, I needed some time to work on it. But yeah, let me see how this sounds with Alma's voice from Monster Hunter Wilds.
Even without that, you should see faster speeds due to removal of CUDA synchronization and more aggressive caching. But in my case, the CPU Windows Python is too slow to fully saturate the GPU.
Yeah, so that one is the exaggeration slider is pretty nice, pretty neat. I do enjoy using the exaggeration slider. Yeah, GPT Soviets, that's my experience too. Some models, it is perfect. Like some models, it does so well. It does laughter, and some nonverbal things very, very well. And then others, like my voice, for example, is hopeless on GPT Soviets. At least me trying to get it to work. But if you've got a more, I think they have a lot of, they have to have a bunch of anime trained voices inside of there. If you are using like an anime style voice for GPT Soviets, or the audio is from anime, it's fairly good. It's fairly good. I think they trained on Genshin Impact, which would be which would be why it's that good. So I think, yeah, maybe if GPT Soviets had a larger training data set, it would be better. But yeah, it's fairly limited from what I remember. But yeah, what have I gone over so far? Yeah, pretty much just those 2 papers, some archive TTS things. Yeah, I'm excited for Index TTS2 to come out. Like I said, this is going to be great for dubbing, so we'll see if that gets released. And then yeah, I'm currently working on trying out like this whole accent conversion thing. But in order to train something like that, I need a data set, and that's what I am spinning up with Chatterbox TTS. So yeah, we'll see how that goes. I wanted to see if I could try to implement this actually. UI code. Okay, so 11 Labs has brackets for emotions. Chatterbox doesn't have it natively. However, let's go into Chatterbox. What's interesting is that if you go into where the heck? If you go into the tokenizer, yes, we do have square brackets that can be used, but they don't actually work because I don't think the dataset had enough of them. So if we go here, we've got like bracket sigh, bracket exhale, inhale, guffaw, laughter, giggle. We've got all of the brackets in here for the tokenizer. The only thing I think that's lacking is the fact that the datasets don't have this annotated. So here we run into another dataset issue, which I think most things is that the datasets are not annotated enough in order for these models to be able to learn them. So I think if we get a dataset with these annotations, I think we should be able to use with Chatterbox. So yeah. Hello there, sudden death, trying to contact me. Discord, Twitch co-host, yada yada yada. Well, I am fairly busy, so I won't be able to do any like work. But if you're just trying to reach out for maybe some ideas, you can hop on in my Discord. I think I do have a link in the description in my videos for the Discord. Yeah. Currently, I am stacked with stuff I'm working on and looking into. So, just gonna lay that out up front. Yeah, using the shorts. I mean, most of these models seem to use a short sample as kind of like the conditioning for speech or reference audio. Yeah, nothing too crazy. I think the more reference audio you have, the less output audio you can have, because what it's doing is it's stacking all those audio tokens before the generation. So I think they all have to do it in one sequence. I think that's how F5 TTS works, which is why F5 TTS, longer audio is not recommended. You want to use shorter bits of audio, or else you'll end up running out of, or else the output audio for F5 TTS will sound rushed. because it's trying to fit all of that into the context window. Lion Ryan, tuning into my stream, huh? What did I hit on squats? Well, I was getting back into squats today, so I only did 3 sets of 5 with 185. But I was looking at my workout log, and it's literally been May since I worked out, which was pretty bad. But yeah, I only did 185 today. But if I'm consistent, it should be 3 times a week squats, 10 pounds per workout, progressive overload. Should be, I don't know. We should be back to 255 pretty soon. But I just gotta get consistent with it. Yeah. Yeah, if not, then it's gonna suck. Hey, you're procrastinating. Don't be one of those guys that's sitting at a bench for 5 minutes on their phone, scrolling through as you're talking to our streamer. Progressive overload, indeed. It's always the way to go. Would definitely recommend it. Okay. Here we are. Reference code. Alright, let's see what was done here. I want to take a look at the diff history. I could probably pool. I think I could probably pool so many files in here. I could probably pull it and check out the diffs and see it. Let me just pull it and see what the difference is. So code it. Go here. Oops. Clear. Git clone. Hey. That's right, Lion. At least you're not procrastinating. That's good. That's good. Have I checked out Kobold CPP TTS? Kobold has a TTS? I thought Kobold was just a web interface, huh? Kobold. No, I have not checked this out, but yeah, from what I remember, yeah, it's part of the UI. Have not gotten a chance to check that out. I don't do a lot of with like those UI stuff, so let me see. I messed up. Git clone. Shoot. Let me make a directory. Look. Test or RSX Chatterbox. CD RSX and then git clone. Okay, so we can go into there and check it out. RSX Chatterbox. Alright, talk to you later, Diane. See you later. Don't mind. What the heck is that? Kawatan? I don't know. What did he say that he changed? To torch compile the generation step. So I can search for this. Okay, did not find it. This looks the same. Let's see what the T3 is. It could be missing the change. Record that incorporates a compilation. Okay, let's see it here. I assume this just builds a extension. Oh, okay, the code of the extension. Okay, so that's how that works. Okay. All right, I'm caught up. Having everything on float 32 increases performance. Okay. Okay, let me pull this and then take a look at it inside of cursor. T32 model comes from here. Can I just do that? Alright, let's see. Get model. Get model. Okay, that's not used. Move model to... Oh no, I'm in the wrong area. Hello? API... Gradio app. There you go. That's right. Okay. This is... Model get current model. So this is from the web UI. Like, what do I need? Get current model. Utils manage model state. Okay. Utils. Manage model state and okay, what I'm trying to do here, I'm just trying to figure out what the model is. If the model is like a modified version of T3, which I don't know. I don't think it is for T3. So I think I could just snatch this and try to figure out how to do the compilation. So I probably do need Dasser's Chatterbox. Okay. Yes. I guess. Is it commits? What are the? Oh no, that's not it. Oh. It's on the fast branch. That's why I wasn't able to see it. Okay. Git clone. Branch facet to track remote branch fast from origin. Okay, I think that's how to do it, how to switch it. Okay. See if there's any mention to compile here. Okay, cool. So that's why I couldn't see it in his repository, because it's in the fast branch. So here we go. We've got it here now. And we do have a custom T3 model here. So I'll pull up my T3 models, T3, and we'll just go through comparisons for setting it up. Or I actually have it here too, so maybe it's just this last part. Compile this self-compilation target. Okay, well, seems like that's it. Maybe. Some other stuff here too. Yeah, I don't think I added anything into here that's any different, so all right. Length guesstimate. Okay. Next iteration inference or training once again. Of free tenses of a prior iteration. Okay. Oops. So this is a guesstimate based on the text token shape. Here, where's this placed at? Where the heck am I? Hey, what's up, Hyperium? Thank you for tuning in. Glad you're able to catch me streaming. Yeah, I'll be on for a little bit longer, and then I've got to go. But Dia 1.6b, it can be fine-tuned. You have to use an unofficial fine-tuning repository for it, though. It's underneath this guy named Stelore. I think his name is Steven. GitHub, oops. Oh, excuse me. Stole. I always mess up on his name. Here you go. Stelore. Stephen Lorray. This repo. Try this out. See if you're able to fine tune it with Dia. So, yeah, this is gonna be it. Yeah, yeah, give that a try. That's how I did a fine tune run with it, and yeah, no problemo, no problemo. Sequence link from. Currently right now I'm just trying to copy and implement a optimization strategy used by this guy who did this Reddit post here for increasing or optimizing the speed of Chatterbox. It's the guy is, what's his name? Robert, I think is his name. Goes over how he's accomplished this here, and given that I'm using Chatterbox, well, I want to see if you know, having speeds or speeding up text-to-speech inference would be preferable. So yeah, just kind of working on that right now. Just checking through the code and copy and pasting. Yeah, nothing too crazy. You know, use standard hung face. Why is it patch it here? Oh, it's just nicely done. Okay. Speech emitting cache. Oh, okay. Okay, so there are some new things implemented in here, so to make things faster for caching, I think. Fast API in Ruby. I don't know any of those, unfortunately, so can't really advise too much. So I'm not the guy for that. So does this here, does this have... Oh, he's not using it, huh? Okay. Yeah, unfortunately, yeah. Since you build most things with Ruby, I wouldn't be, I'm not familiar with that, so I can't give you any guidance, unfortunately. I wish I could. Speech positioning. Okay, let me go through this and see how it's done. Life's not bad. Everything is going fairly well on my end. You know, just working and working on stuff outside of work, and then work out, sleep, eat, rinse, repeat. Yeah. Yourself, how you doing? Let's see. Init patched model gets speech positioning. Cache generation loop. Speech embedding cache. Size. Speech. Oh, and my camera's dead, so I'm gonna need a new one. Well, that might be time for the the stream though, because I have to go. But yeah, I'm gonna unfortunately you guys can't see me right now, so yeah, I am gonna work on this a little bit later once I finish up work and all that stuff. So yeah, I guess my camera is telling me that I gotta get off stream because my battery is dead. So I think, yeah, you tuned in at the end of my basically the end of my stream, so sorry Imperium, but yeah, 9 to 9, you keep it going. That's a lot of work right there. So but glad to hear that you're doing good. Yeah, I'm gonna have to head out, and you guys can see my blank bottom right corner camera screen right now. It's charge up my battery, and then yeah, maybe tune in for another live stream sometime this week. But yeah, thank you to everyone who tuned in for today's short little live stream, just checking out some new AI stuff. And yeah, I hope you guys have a good rest of your day, and I will see you guys later. Peace.